Hi everyone, welcome back to Mathematics Party 3226. So basically this video, in this video, I'm going to cover two most important properties of, triangles as well as quadrilateral. Basically, the two properties are connected to each other. When I'll prove the first property, with the help of that property, I'm going to prove the second property. So yes, this video is all about these two properties. I'm going to cover just these two properties questions. Also, these two properties are very, very important for you. So if you have any doubt like how to prove these two properties, with the help of this video, you can understand it absolutely in the best way. So let's get started with the video without any late, and let's see the properties first. What are the properties that I'm going to cover? So as you can see here, the two properties are, the first property is that the sum of any two sides of a triangle is always greater than the third side. I hope you have heard about this property, but you have never seen the proof, or maybe even if you have seen the proof, you have not understood it, maybe. So yes, in this video, I'm going to cover this particular property, which is very, very important. I have already covered one of the most important properties of a triangle, which is the sum of the interior angles of a triangle is 180 degree. So that I have already covered. So if you have not watched that video, go and watch that video, please. And this video, of course, you can see that this is another most important properties, of a triangle, that the sum of any two sides of a triangle is always greater than the third side. For example, you know that in a triangle, we have three sides. If you take any two sides and if you do the sum, it should always be greater than the third side. If that is not possible, if you're suppose you're adding two sides and their sum is lesser than the third side, that means such triangle is not possible. We cannot draw such triangle, all right? So this is the property. And in the second one, as you can see, the property says the sum of all four sides of a quadrilateral is less than twice the sum of its diagonals, all right? Now, absolutely, I'm going to explain this in detail, and you will see how the second property is connected to the first property. All right. So let's get started with the video now. Before, just a second, before starting with the properties and the proof, I just want to tell you, if you're new to this channel, please subscribe to the channel and don't forget to press the bell icon as well, because whenever I'll be putting a new video, you will get notified uh, if you will press it on the bell icon. So yes, if you have subscribed, then don't forget to press on the bell icon as well. So yes, now we can start with the proof. So the first one, as you can already see, the sum of any two sides of a triangle is always greater than the third side. So let's quickly start with the first proof. All right. So I'm just writing here first proof. Of course, it is about triangles, so we have to draw a triangle first. So let's draw a triangle. All right. Yes. And as you can see in this triangle, basically, I'm just going to put it a little bit here. Yes. So let me just name the vertices. This is A, this is B, and this is C. All right. Now, of course, the given thing here is that ABC is a triangle. Okay. So let's write down the given things. Okay. I have started with the proof. That's how you should write down in your exam also. That's the proper way I'm just following here. So if you want, you can properly write like this only. I'm not just telling you to learn it. Absolutely not. My intention is never to, ask you to learn what I'm explaining you. Understand it and try to put it in your own words as well. So yes, here you can see that given that ABC is a triangle. All right. That's the first given information we have. ABC is a triangle. Now, what we have to prove, that we will write down. So what do we have to prove? To prove, so you can see here that we have basically, three conditions. See, first is, if I take the sum of AB and AC, so AB plus AC should be greater than BC. But is it possible that we have only this condition? No, we have some other conditions also, because that is why in the property it says that the sum of any two sides of a triangle, right? So here I have taken AB plus AC, but someone can also take AB plus BC. And if I'm taking AB plus BC, that should be greater than AC. There is one last condition. If I take AC and CB, that should be greater than AB. So these are the three conditions. Of course, you're not going to prove all the three conditions. You can just prove any one, and for the others too, you can just use a very famous word that we normally use in math. Similarly, we can prove the other two as well, and hence prove. This is what we have to do. Now talking about what do we have to do here? We have to do something extra here, and that is our construction. So what's the construction here? That we have to produce BA. All right, we have to produce BA to a point, let's say D. All right, so produce BA to a point D and join AC. Sorry, not join AC, join CD. Also, we have to produce BA to D in such a way. All right, so produce BA to D and join CD in such a way that the length of AD, all right, the length of AD will be equal to the length of AC. That's our construction. So let's do the construction. So because we always do our construction using dotted lines, so I'm trying to draw it here using the dotted lines, all right? So even if maybe it will not look straight, so you can use, of course, a scale. I'm just trying my best here. And then we have to join this CD, all right, because that's what I have written in the construction. All right, I hope it is looking a straight line. So yes, you can write down here D. And what we have done here, we have produced BA to D in such a way that the length of AD, all right, the length of AD equals the length of AC. This is what we have done here. Now let's get started with the proof. All right, we are done with the construction. We have written the given part. We have also written what do we have to prove. So now we can start with the proof. So the first thing that we have done here is using our construction. So you can write down, by construction, we have done one thing. What we have done? That AD equals AC. Now here I'm going to use one very important property of a triangle, that if we have, two opposite sides equal, then the opposite angles are always equal. All right, this is a property. This is a theorem, we can say. So because we have AD equals AC, so what's the opposite to the side AD? Which angle is present opposite to the side AD? Let's check with the help of this diagram. So of course, this is the side AD. All right, I'm gonna annotate here also. So this is the side AD, as you can see. This is the side. With this side, what's the opposite angle present to this side? Of course, the opposite angle is this. So therefore, angle ACD will be equal to, what is AC? The opposite of AC. This is the side AC. The angle which is present opposite to AC is this, which is angle ADC. That's why using this property, that whenever we have the two sides equal, then the angles opposite to the two sides which are equal are also equal. So that's the property we are going to use here. So we can write down now directly here, because we got by construction AD equals AC. So therefore the angle which is present opposite to AD is angle ACD, and the angle which is present opposite to AC is angle ADC. These two are going to be equal. All right, so I can write down this as equation 1. All right, now imagine we are taking this triangle. All right, so if I'm considering, all right, I'm just putting it here only so that I don't have to go up and down. So yes, so for example, suppose I'm writing angle BCA. All right, angle BCA and angle ACD. All right, let's write down that. I'm just writing angle BCA plus angle ACD. So which two angles I'm taking? I am taking these two angles. I'm taking this angle plus this angle. Don't you think that if I add this angle and this angle, the sum of these two angles will of course be greater than just this angle? I can write it down. So let's write down that. So angle BCA plus angle ACD, of course, it's pretty much clear that they are going to be greater than just angle ACD. All right. Now here we can do one thing. Here we can write down this as angle BCA. All right. Angle BCA plus angle ACD as it is greater than, instead of angle ACD, from this equation 1, I can replace it with angle ADC. How I did this? From equation 1, right? From equation 1. Now, if you carefully do the sum of angle BCA and angle ACD, let's look at the diagram and let's see what is it. If I do the sum of angle, all right, if I do the sum of angle BCA plus angle ACD, that means we are talking about this angle. So can we not write down this as angle BCD directly? Yes, we can write down. So what is that? That will become angle BCD. So this is nothing but angle BCD is greater than angle ADC. Now, because we know that if we have two sides equal, the angles opposite to them are also equal. Similarly, we have this property the other way around as well. Now here, because we are getting angle BCD, all right. So what's this side opposite to angle BCD? Let's look at the diagram. So if this is angle BCD, all right, this is angle BCD, that the side opposite to this angle is of course this side BD, right? So we can write down BD, all right. And then of course we have another angle also, which let's see one more time. So we can write down here, of course, angle BCD. All right, angle BCD. So instead of angle BCD, we can write down here AD. So AD is going to be greater than angle ADC. Let's check which side is present opposite to angle ADC. Of course, opposite to angle ADC, the side which is present opposite to this angle is AC. So we can write down this as AC. Now you can notice one thing here, that we can write down this AD as AB plus AD, right? Because AD is nothing but the sum of AB plus, all right, just a moment. Okay, I have written AD, which is not AD basically, just a moment. It's BD, all right? Yeah, it's not AD, it's BD. Yes. And now we can write down this BD as AB plus AD greater than AC, correct? Now you can notice here one thing, all right? You can notice that AB plus AD, but AD equals AC, that we already got using what? Using our construction. So we can write down, instead of AD, we can write down AC, right? So this will become AB plus AD, right? So here AD, at the place of AD, we can write down AC, right? Greater than AC we are getting. Let's check here one thing. Angle ADC. Yeah, angle ADC. And that will be equal to, just a moment. Let me just check what is the next thing that I have to write down. Just a moment. Angle BDC. Yeah. So here we need to do one thing. See, I have written angle ADC, right? The side which is present opposite to angle ADC is not AC. The side present opposite to angle ADC is BC. Okay. So here, instead of AC, we have to write down BC. That's the mistake. All right. Yes. So this will become BC. Because what is the property? The property is the side which is present opposite to the angle. So here, if you consider angle ADC, let's look at the diagram again. Yeah. So as you can notice here, that this is the angle ADC, right? Now, the side present opposite to this is not AC. That is not correct. The side which is present opposite to angle ADC is BC. All right. So that was the mistake. All right. So here, please don't write down AC. It is basically BC. And how I got it? Because with the help of, the steps only, I got it. Okay, no, it is not possible that here also AC will come. Here BC will come, and that's quite obvious now. So yes, we got AB plus AC greater than BC. Don't you think that we got our required result? We wanted to prove AB plus AC greater than BC, and we got it. So because we got it AB plus AC greater than BC, so we can write down proved, because this is what we wanted to prove. Now, because we have proved this, the other two we can just use, as I had already told you, use this word similarly. We can just write down the other two statements as it is. All right. So similarly, we can prove the other two as well in the exam also. Okay. In the exam, let me tell you that you can directly write down, just do the proof of one, and then the other two you can just write down by using the word this, by using this word similarly. So yeah, similarly, we can just prove that the sum of these two sides is also greater than the third side. That means AB plus BC is greater than AC, AC plus CD is greater than EB, and we have proved this also. All right. And therefore, we can write down sum of any two sides of a triangle, sum of any two sides of a triangle is always greater than the third side. All right, we are done with the proof. I hope you understood this proof. If you have any doubt, because I have cleared almost all the doubts, all the steps. Okay, there is no such step that I have written, which is, I have written just randomly. No, there is a reason behind each and every step. So yes, I hope you have understood this particular property properly. So yes, sum of any two sides of a triangle is always greater than the third side. Proved. Yeah, we have finally written this word, proved. All right, so we are done with the first property. And as I said, the second property is going to be related to the first property. All right, so let's quickly do the proof of the second one as well. Now, because we have the proof of the first property, we are going to use the first property to prove the second property. So let's get started with the second proof now. Just a moment. So yes, that's our second proof, as you can see. So we have to prove this now, that sum of all the four sides of a quadrilateral is less than twice the sum of its diagonals. So with the help of statement, maybe it's not very much clear, but now when I'll draw the diagram, it is going to be quite simple for you. So let's name it A, B, C, D. Because here we are also talking about diagonals, so let's draw the diagonals as well. So this is our first diagonal BC, and the second one is AD. And now what is given in the statement, I'm going to write down using a mathematical, equation. The sum of all four sides. So sum of all four sides meaning AB plus BD plus DC plus CA is less than, all right, is less than twice the sum of, that means twice the sum of its diagonals, that means AD plus BC. That's the statement. We need to prove this. We need to prove this particular thing. All right. So let's quickly start with the proof, because it's very simple and very straightforward, because we have already understood the first one. So this one is going to be very simple. Now let's imagine that both the diagonals cut each other at a point O. All right. So let's write down there is nothing to write down in the given here, but of course, when you're writing this in your exam, please write down just given that ABCD is a quadrilateral, AC and BD are, sorry, AD and BC are diagonals passing at, cutting both the diagonals at point O, like that you can write down, all right? So here the given part, I'm just writing it blank, all right? And I'm expecting that you can write down that ABCD is a quadrilateral, AD and BC are diagonals, and so on. And then let's get started with the proof directly. All right, so please fill this. I just want you to write down, the answer in your examination hall in the best way. So don't forget to write down the given part as well. All right, so I'm starting here with the proof. So here you can see that we can see 4 triangles are being formed, all right? So let's start with the first triangle, which is in triangle OCD. In triangle OCD, I'm going to use the property. Which property? The property that we have already proved. In a triangle, the sum of 2 sides is always greater than the third side. So in triangle OCD, I'm just taking the sum of OC plus OD has to be greater than CD. Why? By first property. So here I'm just writing by property 1, but in case you are getting this question in your exam, don't write it by property 1 because they don't know what's written in the property 1. But here, because I have already proved, I have already written a statement in property 1, so I'm just writing by property 1. What you are supposed to write down, you just write down since the sum of any 2 sides of a triangle is always greater than the third side. That's it. Here, instead of writing that statement, or that sentence, I'm just using by property 1. So let's put this as equation 1. All right. Now, again, we can consider our second triangle, which is in triangle ODB. I can do OD plus OB is greater than BD, of course. This also I'm putting as equation 2, of course. Now let's take in triangle AOB. All right. So I'm writing here only. So in triangle AOB, we can write down OA plus OB is greater than AB. Again, by using the property, okay, I have not written here. But please make sure you are writing the reason as well. All right, by property 1 again. And this I'm putting as equation 3. All right. And we can see one more triangle, which is triangle AOC. Let's write down that also. So in triangle AOC, we can write down OA plus OC is greater than EC. Again, by property 1. And let's put this as equation 4. Now, do you know what we are going to do? We are just going to add our all 4 equations. So we can write down 1 plus 2 plus 3 plus 4. Always remember that whenever we are adding any equation or any inequations, we always add the LHS, we always add the RHS, all right? So here in equation 1, we have on the LHS, that means left-hand side, OC plus OD. Then let's move to the second equation and let's just write down the LHS part, plus OD plus OB. Correct? And then we have OA plus OB. Correct? And then we have plus OA plus OC. And then is greater than, we are getting CD plus, I'm now writing the RHS part. So CD plus BD plus AB plus AC. All right. Now you can see here one thing, that OC plus OD plus OD plus OB. You can notice here that some of the terms are coming 2 times, right? So at the place of OC plus OC, I can write down 2OC. At the place of OD plus OD, I can write down twice of OD. And at the place of OB plus OB, I can write down twice of OB. Plus at the rate of OA plus OA, I can write down twice of OA. Is greater than, I can just write on this as AB plus Okay, this is BD, I think. I think it should be BC only. All right, let me just check what is the mistake. Let me check. Okay, I have taken in a different way, A, B, D, C. All right, okay, no problem. But make sure you're writing like A, B, C, D. Here I have taken A, B, D, C. So no problem. So I can write on AB plus BD plus DC or CD plus AC. All right, and here you can see that twice of OC plus twice of OD plus twice of OB plus twice of OA. I can take here 2 common and I can write down this as OC plus OD plus OB plus OA greater than AB plus BD plus DC plus AC. All right. Moment. Yeah, that's correct. Now you can see here that if I add OC plus OB, all right, if I add OC plus OB, am I not getting BC? I am getting BC, right? So I can write down this as OC plus OB. So that means OC plus OB, I can write down BC. So twice of BC plus OD plus OA is nothing but AD, all right? So that will become AD and greater than AB plus BD plus DC plus AC. And this is what we wanted to prove, that the sum of all the sides of a quadrilateral, which is AB plus BD plus DC plus AC, is less than, okay, because I'm writing this part here on the LHS, of course, that part is lesser than. So less than twice of BC plus AD, the twice of the sum of its diagonals. This is what we wanted to prove. So we can write down hence 2, the best part. And we are done with both the properties. I hope you understood these 2 properties, which I explained just now. In case if you have any doubt in these 2 properties, let me know in the comment section, because I will understand whether I'm able to put, to make you understand these things in a proper way or not. So please give me the feedback also, so that I can, I can get some idea that how much you are understanding and all those things. All right, so yes, we are done with our video for today. I hope you understood this. I hope you are enjoying all my videos. And once again, I just want to say that if you're new to this channel, please subscribe to the channel. And if you have already subscribed to the channel, don't forget to press the bell icon, so that in every, like next time, whenever I'll upload a video, you will get the notification. All right. So thank you so much for your support. Keep loving and keep supporting this channel. Thank you so much, and see you super soon next time with the next concept and a next maths video. Till then, bye. Take care. Thank you.